Hi everyone, welcome to our next lesson. Now today's lesson is quite a tricky topic, which means I would like you to take these note-taking and the video part quite slowly. There are going to be practice questions, and whereas if we were in school I would do this in one lesson, I'm actually going to split it up over two. So that next time I see you, we'll also carry on with this. So if you're not 100% sure at the end of this lesson, that's okay, because you have another lesson to have a go at it. So the first thing we're going to do is just have a look at some circuit symbols. I'm hoping you remember these. So pause the video and just see if you can name all the different symbols. You'll see all the names are on the right hand side. So all you need to do is in your head, don't need to write anything down, just see if you can match them up. So let's go through, shall we? On the left hand side, top, I'll do this, is a battery. You've then got a single one, that is a cell. You have a variable resistor, bulb, ammeter, voltmeter, switch, that's an open switch obviously, a diode, which we looked at last lesson if you remember. This is the symbol for a thermistor, which again we also looked at last lesson. This is a light dependent resistor, a fuse, which I know we haven't looked at yet, and a resistor. So there you go. If you don't have any of those in your book, could you possibly add them so that you've got a record of them? Thank you. So today we are looking at something called potential divider circuits. Now before we go on to what it is, I want you to just have a think. Can you guess what it is from the name? Hopefully you're noticing potential, like potential difference, and divider. Basically, these are circuits which take a potential difference from a cell or a battery and they divide it between different components. And your aim in these questions is to work out how much potential difference effectively goes to different components. So we've done similar bits before, but we're having a real focus on it now. So the first thing I need you to know and write down is the bigger the resistance of a component in a series circuit, the more potential difference it takes. And I'd also like you to draw that circuit underneath with all the labels. So let's just have a look at that circuit. You have 12 volts coming from the battery on the left-hand side, and you have 3 bulbs. Now these bulbs are clearly not identical because you can see there are 3 resistances. 2 of the bulbs have a resistance of 2 ohms, and the middle bulb has a resistance of 4 ohms. The 2 bulbs on either side take 3 volts of potential difference. However, that middle bulb with a resistance of 4 ohms, you can see it takes 6 volts from the battery. And I've added a label there. This bulb takes double the potential difference as it has double the resistance of the other bulbs. And that's basically what we're going to be looking at today. How resistance and potential difference are related, effectively, not just in Ohm's law. So another way of drawing it, once you've written all of that down, is here. We've got another circuit here. Now this is just another way of drawing a circuit. It is nothing different to what we've looked at before. You've got 6 volts coming from a cell. You have 2 resistors, 10 ohms and 20 ohms. And you can see, if I put a little voltmeter here, that the voltmeter across the 20 ohm resistor is measuring 4 volts. Okay. Now, what you shall be asked in questions is if you were not told this bit, you might be asked to work out, not given any more information, how much potential difference goes across that 20 ohm. And so you'd have to work it out effectively, so let's just get rid of that. So I've just said the bigger the resistance of R2. Now you'll notice now I'm starting to call them R1 and R2. The higher proportion of the input potential difference it takes. Now it doesn't matter really which way around you put R1 and R2, as long as you're consistent when you're working out your equations. So I've just called them R1 and R2 just to make life easy, really. Now there are 2 ways that you can work out potential differences, and I'm going to show you both of them now. So the top one, V1 over V2 equals R1 over R2. And it says, to be used when you don't know the total potential difference of the circuit, the input, you're only comparing the potential difference across two resistors. Now, what I mean by that is, you might have a circuit. Here we go, two resistors. And let's say you know that this one is 3 ohms and this one is 6 ohms. So you know they're two resistances and you know one of their potential differences. But notice we're not given the input. We don't know how much is coming from the battery here. This is when we'd use that top equation, V1, V2 equals R1, R2. So my first tip is label the one that you don't know as number 1. So let's call this one R1 and this one R2. Because that means when you put it into the equation, R1 over R2 equals V1 over V2, it just makes your life easier with a bit of rearranging. If you can't, it's not an issue, just switch the equation over. So you'd have, for goodness sake, R2 over R1 equals V2 over V1. They mean exactly the same thing. Just whatever you are trying to find out, put it on the top in the equation is what I'm trying to say, because it just makes your life easier. Right, so we've got this equation. Let's start plugging in our numbers. So R1 is 6, R2 is 3, V1 is what we're trying to work out, and V2 is 10. So I'm sure you're happy here that you can rearrange that. So 2 equals V1 over 10, V1 equals 20 volts. So if I just pop that in, so I have 20 volts. So can you see I've picked that equation because again, it has nothing to do with the battery. We are not given the input here. We're not given the total. We're only given the information about the two resistors. So that's when I'd use that ratio one. And the second equation is all about basically proportion of the total. So this one is to be used when you know the total potential difference of the circuit and are working out the proportion of the total. So have a look, V2, so I've chosen 2 here to look at, and that means I put R2 on top. If I was looking at V1, I just put R1 on top in the equation. It's exactly the same, you just change the numbers, that's it. So V2 equals R2 over R1 plus R2, and what I mean by that is the total resistance times the total potential difference. Now, this equation basically says, let's say you have an input of 10 volts. If you work out the proportion of the total resistance that your resistor is providing, it'll take the same proportion of the potential difference. So if your resistor provides 30% of the total resistance, it'll take 30% of the potential difference. So again, let's just do that in terms of a question so you can see the difference here. So I have a circuit, and let's say this provides 25 volts. And then I have, do you know what? Why not be devils? Let's give ourselves 3 resistors. It might happen. Let's say 65 ohms, 10 ohms, and what else? 25 ohms. Okay. And you are being asked to work out, so for the sake of it, let's call this R1, R2, and R3. It doesn't matter, I've named them. You are being asked to work out the potential difference across, let's say R3, okay? You want to work out what that potential difference is. So to work it out, you are going to use that second equation. And the reason you're using that is because we know the total potential difference, because it's given to us. It's that one in the question, 25 volts. So that's why I'm using that second one. So let's write it out. So V3, because that's what one is being asked to work out, equals R3 over, now you want the total resistance here. Now remember these are in series, so you just add them all together. R1 plus R2 plus R3, put that in brackets, times V total, so times V total. So let's plug those numbers in. So V3 equals 65 over 65 plus 10 plus 25, in brackets, times 25. Plug that into my calculator, and it comes up with 16.25 volts. So R3 clearly takes 16.25 volts. And that's it. So I'm now going to give you a bit of a practice. Again, if you can please write down this practice question, that'd be fabulous. A 3 ohm resistor and a 5 ohm resistor are in series with each other. The 3 ohm resistor has a potential difference of 6 volts. What is the potential difference of the 5 ohm resistor? Now, first thing to notice is, do you know the total potential difference of the whole circuit? No, you don't. So you use this equation. So write out what you know. Again, I've just chosen to put the one I don't know on top and the corresponding resistor on top. So V1, we don't know. V2, 6 volts. R1, 5 ohms. R2, 3 ohms. Pop it into your equation, fiddle around with the numbers, and it comes out V1 is 10 volts. So the most important thing is picking which equation you need, and you know that by saying, do we know the total potential difference? So here are some practice questions. Pause the video, and then I'm going to go through the answers. So assuming everyone has had a go at this, first thing I'm going to do is I'm going to go through and just write which equation you need to be using here. So question number 1, 2 resistors are in series if the total input potential difference is 10 volts. So we know the total input, which means what we are going to do is use the second equation. V1 equals R1 plus R2 times V total. Okay, so that's the first thing you need to do, pick out your equation. Then let's plug in the numbers. You've got 2 4 ohm resistors, so 4 plus 4 times 10, and the answer is 5 volts. Number 2, a 10 ohm resistor and a 12 ohm resistor are in series. 12 ohm has a potential difference of 24. What's the potential difference of the 10 ohm resistor? Do we know the total input potential difference? No, we do not. So we are going to use this equation, V1, V2, R1, R2. Now we want to work out the potential difference of the 10 ohm resistor. So I'm going to make that one R1. So question mark over, what's the potential difference? 24, 10 over 12 equal, question mark or V1 equals 20 volts. Number 3, a 15 ohm resistor is in series with a 10 ohm resistor. If the total input, that we know this one, so fine, V1 equals R1 plus R2 times V total. How much potential difference is the 15? So 15 over 15 plus 10 times 250 equals V1 equals 150 volts. So as I say, the most important thing is that you know which equation you're using. Do you know the total input? There are some more practice questions on Google Classroom, and as I say, we are doing another lesson on this. It is quite tricky, but please let me know if you need any help. Thanks everyone.